Explaining lower yields. Let's start by defining the different types of yield. Theoretical yield is the amount of product you would expect if 100% of the limiting reactant is converted into product in the reaction. Actual yield is the actual amount of product obtained from the reaction. The actual yield is the actual amount of product obtained from the reaction. In experiments, actual yield is affected by three main factors. Factors that affect the actual yield are the number of transfers of the reaction mixture, the side reactions that occur, and whether the reaction is reversible. More transfers lead to a lower actual yield. Examples of transfers include transfers of liquids from measuring containers to reaction vessels. Transferring a liquid from one container to another will result in loss of small amounts of the liquid. Some of the liquid will be left behind in the original container. Other transfers that can reduce the actual yield are filtering. Not all the residue can be scraped from the filter paper, and not all the filtrate can be transferred to the next step. Solid may also be lost when trying to remove solid product from an evaporating dish, for example. More side reactions also lead to a lower actual yield. Examples of side reactions include impurities in the limiting reactant reacting with other chemicals in the reaction mixture, or the limiting reactant taking part in a different chemical reaction. This is more common in organic reactions. Solid reactants will often contain impurities that result from the manufacturing process. For copper 2 oxide, common impurities are copper carbonate, aluminium oxide, and iron 3 oxide. The amount of these impurities is very small, less than 1%. This means that when you measure out 100 grams of copper 2 oxide, in truth there will only be 99 grams of copper 2 oxide to react. The iron 2 oxide and the aluminium oxide will take part in side reactions. These are chemical reactions that occur at the same time as the main reaction, but may produce a different product. A reversible reaction will lead to a lower actual yield because the reaction will not go to completion. So what is a reversible reaction? A reversible reaction is a chemical reaction in which the products of a reaction can reform the reactants. For a reversible reaction, the reactants are assigned to the substances at the start of the reaction, written on the left of the arrow in the equation, and the products are the substances present at the end of the reaction, written to the right of the arrow. To show the reaction is reversible, the two arrows are replaced by a special reversible reaction arrow. This arrow shows the reaction is reversible. Summary. There are three common reasons why the amount of product made is less than theoretically possible. Firstly, small amounts of chemicals are lost every time the reaction mixture is transferred between containers. Secondly, there may be other side reactions occurring. Finally, if the reaction is reversible, then it may be an equilibrium, in which case the reaction will not go to completion. Keywords: actual yield, the amount of product actually obtained from a reaction. Limiting reactant, the reactant that is completely used up in a chemical reaction. It limits the amount of product formed. Reversible reaction, a chemical reaction in which the products of a reaction can reform the reactants, so is unlikely to reach completion. Side reaction, a chemical reaction that occurs at the same time as the main reaction, but produces a different product.